After we designed our lateral, submain and mainline, we need to go over to system summary to check if the flow rate that we have is enough to irrigate the full area that we want to irrigate. So head over to system summary and fill in the information that we see here in red. Let's say that we have an area of 50 hectares to irrigate, and the emitter spacing is 0.3. Number of laterals per row, we will select 1, but there are examples where in projects we are using more than 1 lateral per 1 row. So for our example, we will be using 1 lateral per row. Lateral spacing 1.4 meters. Max daily consumption. Let's say that we want to irrigate a maximum of 10 millimeters per day. And we have a water source of 200 cubic meter per hour. All the information that we see here in this graphical part of the hydraulic tool are imported from our previous calculations. So from the lateral calculation, submain calculation, mainline calculation, and all of this information is imported here into the system summary tab. We can click calculate. What are we missing here? Maximum irrigation time per day. Let's say we want to irrigate in 20 hours. Click calculate, and the software tells us that our water source is not enough. In order to irrigate 10 millimeters per day in 20 hours, we will be needing more than 200 cubic meter per hour. We will need 303 cubic meter per hour. Let's say we decrease our irrigated surface to 30 hectares. Click calculate, and we see that for 30 hectares we have enough water. So for 30 hectares we can divide the field into 4 cycles, into 4 shifts. Each shift will need to operate 4 hours, 4.1 hours, in order to deliver the 10 millimeters, because the average irrigation rate will be 2.4 millimeters per hour. So 2.4 millimeters per hour times 4 hours, we will have 10 millimeters applied in the field. And in order to achieve this, we will need a flow rate of 182 cubic meter per hour. And we will not need 20 hours to do this. We will just need 16.4 hours. So 5 shifts of 4 hours each equals a total irrigation time of 16 hours. We can also show a detailed report of all of our systems. So here we will see the information regarding our lateral, the internal diameter, the hydraulic coefficients, the slopes in case we added some slopes or not, the emission uniformity, and so on. And then we have a report on the submain. In our calculations we decided to use 164 meters of 125 millimeter pipe plus 36 meters of 110 millimeter pipe, because for our example, we choose a 200 meter submain. This is the flow rate in the submain, and then we have a detailed report on the main line. For our example, we choose a 500 meter 125 millimeter pipe. We have here the interior diameter and the velocity in this pipe, and then a report of our head losses in different areas. So in the filtration area, in the valve in the field, inlet pressure in the lateral, and so on. So this is a full report of our system. You can export that into Excel file and show it to your customer.